Hey folks, welcome back. Welcome back. I'm happy to be welcoming you back from what was hopefully a restful April break. It's actually still not over for me since I'm writing this. I'm actually doing this out on Sunday. But welcome back. I hope you were able to get a lot of relaxation out of this. I appreciate for those of you who are really putting in a strong effort, I really appreciate everything you're doing. And for those of you who are still working to get caught up, I hope that that's something that we can make happen over the coming days, right? Especially with the announcement, right, that we're probably not going to be going back. Actually, we're definitely not going to be going back anytime this current school year. Um, so what we're going to do is we're going to move ahead and we're going to continue to talk about a little bit of quadratics and factoring and solving just to keep your skills sharp. And then at the same time, I'm also going to be introducing you to geometric sequences, and we're going to talk a little bit about exponential functions as well. Okay, so what I have for you is this. I've got for you these two equations. Okay, the first one is 8j squared plus j minus 30 equals 0. And then the second is 100p squared plus 54p plus 15 equals 6 minus 6p. So you need to solve those, finding any values of j or p that make the equation true. And then I need you to write a rule that goes with the sequence you see here. 3, 6, 12, 24, and so on. Okay? So what I want you to do, pause the video, try to solve these problems, all right? And then when you're ready, unpause, and I'll show you what I got. Okay, so hopefully you're able to make an attempt on these. At the very least, maybe this will provide you with a little bit of a refresher on some of the important ideas we've been talking about. So the first one here is a factoring problem. Okay, it's factoring because we see a value of b is there, so we know we're going to need to factor. So I'm going to open up a box. Okay, I'm going to put the box in the box, 8j squared negative 30. So I essentially need these two to multiply to 8j squared, and these two need to multiply to negative 30, and then I've got to get 1 when I add these up. So to get 8, this is tricky because I could have 1 or 8, 2 and 4, and 30 I can have 1 and 30, 2 and 15, 3 and 10, or 5 and 6. Okay, so there's a lot of different combinations. Now getting it to add up to 1, that's also, right, getting these boxes to add up to, these have to add up to just 1j. That's tricky also, right? So I got to think about the combinations. So I'm thinking, like, where would I start first if I was going to start this off? And maybe what I would do is, I don't know, let's start with 2 and 4. Suppose those were it. Okay. So now I got to see if I can get these. Now I know one of them is positive and one of them is negative, because a positive times a negative is a negative. And now let's see. Ooh, this is not easy. So let's say I'm thinking this will be a 6 and this will be a 5. And I'm thinking this will be a positive 5 and maybe a negative 6. So this would give me negative 12 and 20. Okay, so that's nowhere close. And I don't think reversing it's going to make a difference. 24 and 20. So no, not really. Okay. So just let's keep messing around with it. So it's not 5 and 6. Let's see. If I do 10, this would be 20. We have 20 minus 12. Nope. If this was a 10, we have 40. That'd be way off. That would be way, way off. So I'm starting to think maybe our other possibility is that it's 8 and 1. Okay, as the J combination. Now this is kind of cool because I can't put, for example, a 6 here or 2 here, because then these would have a GCF, and I know these don't have a GCF, because if these had a GCF, there would have been a GCF here, and I can see that is not the case. So let's see, what could I get to add up, knowing that I've also got 1? It's not easy to do these ones, as you can see. I thought I just saw 1, but I thought I saw it with like the 30 and the 1, but I don't think I think I've got it. So this needs to be 15, and this needs to be -2. Actually, no, other way around. This needs to be 2, and this needs to be -15. So I get 16j minus 15j is equal to 1j. So I don't teach the tricks, and remember, the reason I don't teach these tricks is because they're so hard to memorize, and if you can just think about getting the things to multiply out, that's a way that reliably works, that always gets you a solution, and there's no real tricks to that. Okay, and now I need to solve this. So either 8j minus 15 is 0, because these things are multiplying to get 0. So j equals 15 over 8. Or j plus 2 is 0. So j equals -2. Okay, those are our two solutions. Okay, coming down to the next one, I've also got factoring potentially. What I think I'm going to start by doing, and I don't know why I just had that happen, but it's all right. I'm going to start by trying to make this equal to 0 here. So what I'm going to do is I'm going to subtract 6 and add 6p minus 6. Okay, because I see p's and it doesn't look like these are going to cancel out. So I've got 100p squared plus 60p plus 9 equals 0. Okay, and interestingly, this is going to be factoring, but what's interesting is that the first number, the a, and the c are both perfect squares. So when I do my box, right, I know that this is going to be a 9 and it's going to be 100. Okay, so what that means is that, for example, let's try it with this is 10 and this is 10, and since this is positive, well, it could be a positive or a negative, but since this is positive, the 60, let's try this. So I do this, I get 30p and 30p for 60p. Perfect. So this is 10p plus 3 times 10p plus 3, and since these are the same, you can rewrite that as 10p plus 3 squared. So we just have to solve 10p plus 3 equals 0, and the answer to that is p equals -3/10, or -0.3. Okay, and the last one, we have writing the rule. So this is what we call an explicit and recursive rule that we need to write, and this is the sequence, though, is what we call a geometric sequence. And the reason is because it's, as we go from term to term, we're multiplying. Remember, arithmetic is when we're adding, geometric is when we are multiplying. Okay, so what we learned is that the idea of taking a number and multiplying it over and over by a certain number of times, that's like raising it to a power. Okay, so for our explicit rule, we're going to have our ratio to the power of n, because we're multiplying by that ratio over and over. Okay, remember the 2 is called the common ratio. Okay, so what we're looking for is a function that looks like this: a times 2 to the n. Okay, and what we know is that, for example, when I plug in 1, I need to get 3. When I plug in 2, I need to get 6. When I plug in 3, I need to get 12. When I plug in 4, I need to get 24. Okay, so for example, if f of n is 3, then n is equal to 1. And 2 to the 1 is 2. So to get a alone, you just divide, and you get a is equal to 3 over 2, or 1.5. So my final explicit rule is f of n equals 3 over 2 times 2 to the power of n, or 1.5 times 2 to the power of n. Okay, either one of those would work. Okay, this is the explicit. For the recursive, so we have to talk first. What's the first term? The first term is 3. Okay, and then to get every other term, okay, remember, this is what they all look like this. And then what do we do to get from term to term? So to get to the second term from the first term, we do what? We multiply by 2. To get from the second term to the third term, we multiply by 2. To get from the third term to the fourth term, we multiply by 2. So imagine I wanted to know the fifth term. Using this rule, what would I do? I would take the fourth term and I'd multiply by 2. And then if I wanted the sixth term, I would take the fifth term and multiply by 2. And so if I wanted any other term other than the first, what I'm doing is I'm going back to the last term and I'm multiplying by 2. Okay? So hopefully you found this video to be helpful and you were able to get these right. Today we are going to do a good focus on geometric sequences. And so we're going to be working a little bit more on that. So keep up with the good work. Keep the questions coming. I'm looking forward to jumping back into things. And remember, folks, as I always say, you can do it. All right. Have a great day. Don't forget to love math.